Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS and we have been covering paper 3. In this paper 3, we have started the topic sampling techniques and in the previous lecture we finished two-stage sampling. In today's lecture, we'll start with the new sampling technique which is varying probability sampling. So as we all know that varying probability sampling. In simple random sampling, each unit is selected with equal probability, which was the basic, which was our basic technique or sampling technique, which is the first sampling technique that we learned about, is simple random sampling. The probability of selecting every unit in the sample is equal. Suppose we are selecting ith unit, then it is 1 upon n. If we are selecting second unit, then also it is 1 upon n. The probability remains same. But to obtain in under certain circumstances, to obtain more efficient estimator, the probability of selection of units may differ. And when this probability differ, then this technique is known as varying probability sampling. So in simple random sampling, if we are taking first unit, suppose there are n units, x1, x2 up till xn. So in simple random sampling, the probability of selection of 1 is also 1 upon n, 2 is also 1 upon n, and so on. N is also 1 upon n. The probability remains same. But in varying probability sampling, the probability of selection of one unit, let it be 1 upon 2n, let it be 1 upon 5n, let it be 1 upon 11n. So all these probability differ, and hence it is known as varying probability sampling. Now varying probability sampling is considered on y. Y is our study variable, and x is our auxiliary variable. So the study is conducted on y, and where x is the auxiliary variable, and the selection of the auxiliary variable depends on has different probability of selection as compared to simple random sampling, which we were doing previously. So now there are two types of auxiliary varying probability techniques. If we vary probability sampling, this can be further divided into two techniques. One is probability proportional to size with the replacement. This is also known as PPS and probability proportional to size without replacement. Or this can also be written as PPS. These are the two varying probability sampling techniques, probability proportional to size with replacement and probability proportional to size without replacement. Now, what is probability proportional to size? So, probability proportional to size, if we take a large sample, बंद हो गया? So probability proportional to size. If we select a sample, selection of a sample on the basis of size. So if we are selecting xi sample, then it is proportional to its size. Or we can say probability, if we are probability of selection of ith term in the sample is directly proportional to the size of the sample, which is xi. So probability proportional to size is we select the samples that may be having larger size or that may be having smaller size according to the study we are conducting. So this is considered one of the example in this is when we use agriculture, when we have to determine agriculture yield. So for the agriculture yield, we will take more larger number of land, having more number of crops as compared to a smaller number of land, which will give us a small amount of uh, uh, a small amount of details which we require instead of a larger number of land. So we are considering the size of the land here. So this is the example of probability proportional to size. So moving on to probability proportional to size with replacement. Probability proportional to size with replacement. In probability proportional to size with replacement, the selection of every unit has constant chance or probability. It doesn't change. Suppose we have been given a sample x1, x2, x3, and the probability of selection of x1 was 1 upon 5. The probability of selection of x2 was 1 upon 2. The probability of selection of x3 was 1 upon 3. Suppose these are the probabilities. So if we select x1 and we have taken the probability 1 upon 5, and then we'll replace back in the population. So after that, if we select x1 again, then the probability of selection of xi remains constant. It is constant at every draw. So at every draw, our probability of selection of a particular unit remains constant. Though the probabilities are not constant within themselves in the population, but the probability of selection of that ith sample remains constant. So let us take there are two processes which are considered for a measurement of this probability proportional to sample with replacement. First one is cumulative total sum and the second one is Lahiri's method. So probability proportional to size with replacement have two processes: cumulative probability total cumulative total sum and Lahiri's method. This is useful for smaller sample and this is useful for larger sample. So in simple random sampling, when we had to select the n units from capital N population, suppose the population has size capital N and sample, we have to select a sample of size small n. So small n used to be always less than equal to capital N. Here also we'll select a sample of size small n and we have the population of size capital N. So how does cumulative total uh, process done here? Total method. So here these are unit sizes and cumulative total. So first is first unit, selection of first unit, then second unit, then ith unit, then nth unit. So size of first unit is x1, size of second unit is x2, size of ith unit is xi, and size of nth unit is xn. So cumulative total. First one cumulative total would be x1 only. This is the cumulative frequency total that we used to do in our frequency table. Exactly the same we'll be doing for sizes. T2 is equals to cumulative total of size 1 and size 2. And Ti is equals to sum of j goes from 1 to I minus 1 xj. Then T summation j goes from 1 to n capital N Tn goes is xj. So this is the table or cumulative total method that we used for our calculation of PPS with replacement. And now the steps are: select any random number between 1 to capital N. Let us say that it is R. We have selected a random number R from 1 to N. Now the second step is, if R falls between xi minus 1 and xi, or this was if R falls between ti minus 1 and ti, then we select the ith term ti with probability xi upon t n, where for all I goes from 1 to capital N. Here now repeat the same procedure small n times, because we have to calculate the sample of size small n. We have to repeat the small m times, so as to get a sample of size small n. So these were the three steps that we have to follow. Now the probability of selecting of ith unit. Probability of selecting ith unit in the sample, in the population, or we can write only selection. It is understood that we are selecting from the population. Probability of selecting, which is denoted by pi, is nothing but x, sorry, t I minus Ti minus 1 upon T capital N. Ti minus Ti minus 1 is nothing but xi upon Tn. And from this we can conclude that probability of selection of ith unit is directly proportional to the size of the ith unit, and hence it is known as PPS with replacement. Probability proportional to size with replacement, where for all I goes to from 1 to capital N. Now, this method is useful for small sample if we have a size of 10, 12, 20, up till maybe 50 also. But if we have a size of 100 units, then what? So the drawback of cumulative total method is given by, the drawback of cumulative total method is, first of all, not very tedious for larger sample. Second is, it is very time consuming. So these two methods These two reasons make this process a very tedious task and is not fit for using for all samples. So for this, to overcome these hurdles or these problems, we use Lahiri's method. Many questions in the PYQs have been asked on cumulative sum total method, or the definition of the cumulative total sum method, or the differentiation between Lahiri's method and cumulative total sum method. So I hope it is clear from today's lecture. Lahiri's method will continue in the next lecture, and that will complete our PPS with replacement. And we'll go to again, we'll move forward to PPS without replacement and follow the methods that includes in it. I hope you got that we have done today. Keep on working hard and keep on watching the lecture videos. If you find anything which is doubtful, then you can ask in our comment section or WhatsApp channel. Our only relevant doubts will be answered. All the best. Thank you.